eBay is a major online market. Since it is such a significant component of the economy, online auction dynamics and bidder behavior are both academically and practically interesting topics to investigate. In particular, we tried to predict the final prices of cars, which are among the more valuable items sold on eBay. One method is motivated by the fact that any given observation adds to the elapsed time of an auction, in addition to adding to the bid price. The method thus involves non-parametric bootstrap draws from the joint empirical distribution of time increments and bid increments, which were used to simulate auction progressions for each member of the test set. We draw until the elapsed time exceeds the end time of the auction, and we call the penultimate price the predicted price. All of the bootstrap methods performed pretty atrociously, probably because we couldn't make the subcategories for the empirical distribution fine enough without running into sparsity issues. However, linear regressions allow us to account for any values of characteristics like mileage and year, without having to group them into coarse categories. Our next model is thus a linear regression on auction characteristics and prices at 2 points in the auction, the start price and the price at 9/10 of the auction runtime. The characteristics we used were auction length, the square root of mileage, starting price, and the square root of car age. This method produced a much lower average error than all of our bootstrap methods. Our last method is a 3-factor linear model with weights trained on price level, velocity of price, and acceleration of price. The most common bid history shape looks generally cubic, motivating the idea that price level, velocity, and acceleration at a given point in an auction can be used to predict the final price. This model performed very well in terms of error percentages, but is limited to predicting prices for auctions with at least 20 bids. We learned a lot throughout the project during every step of the data collecting, cleaning, and analyzing process. We were happy to have a chance to apply what we learned this semester in CS 109. Thank you for viewing our presentation.